Chapter 2, Section 2.1, Quadratic Functions and Models. Here are our section objectives. And we're going to start by looking at the graph of a quadratic function. When we are, looking at polynomial functions in general, here's our general format. And this would be any n, your n is your exponent, your power. It could be any non-negative number or non-negative integer, sorry. So like 1 or 2 or 3 or 4. And so in this section, we're specifically going to look at when the power is 2. If the power is 2, it is a quadratic function. So it's going to be a special graph. We're going to call it a parabola. It's a U shape. There is an axis of symmetry vertically right down the middle of these. And we'll be looking specifically at a point on the parabola, the vertex, which is going to be right at the turning point. One thing that we'll see consistently is this leading coefficient A. If it's positive, your parabola will open up. If it's negative, your parabola will open down. So we'll try a couple of examples here. First, we'll try 1/3 x squared. So y equals 1/3 x squared. So I'm going to first put in my axes so that I have something to go off of. And I'll just have all of these be a scale of 1. So every line represents 1. So first, my parent function, y equals x squared, that is the one that has not been moved at all. So this is a parent or a regular parabola, okay? If you are going to change it and make it 1/3 x squared, you have to think about what that 1/3 would do to your function, and it would take every y value and multiply it by 1/3. So instead of over 1 up 1 for that first point, it'll be over 1 up 1/3. That is over 1 up 1/3. Instead of over 2 up 4, it's going to be over 2 up 4/3. So the 4 has gotten divided by 3. So over 2 up 4/3. And then start to make a parabola. All right, so that is my y equals 1/3 x squared. So you see when the 1/3 is out in front, it's going to make it shorter. It's a vertical compression or like a vertical shrink. The next one, you can graph that parent function every single time if you want. I like to have that as like my guide. This is just my regular y equals x squared without any transformations on it. And this one has a 2 there. So now my y values are doubled. So instead of over 1 up 1, it's over 1 up 2. Instead of over 1 up 4, instead of over 2 up 4, it's over 2 up 8. So the x values stay the same and the y values get doubled. So if you plot these points for this parabola, it is a vertical stretch. It got taller, so it looks narrower. All right, standard form of a quadratic function is what I think of as user-friendly. If you have it in this format, you can get your vertex, which is h and k. The vertex is h and k, and you can get your a value easily. It tells you if it's pointing up or pointing down. It tells you the vertical stretch or compress or shrink. So it gives you a lot of information. If you are given an equation that's not in standard form, this is in general form, just, written out with any parentheses, you can't get your vertex easily. So when we have something in this format, we are going to want to change it into standard form, and we do that by doing something called complete the square. And complete the square is just a process where we are going to change it from this general form where it's, no parentheses into parentheses so we can grab that vertex easily. So how we're going to do that is first, we're going to take just the first two terms and factor out the coefficient. We really want the coefficient of x squared to be 1. So I'm going to factor out a 2. And I'm going to leave a spot. That's where I'm going to complete the square. That's why that's there. And then the plus 7 is going to stay out. Now, complete the square is where you want to pick a number so that the stuff in the parentheses is factorable. And it's factorable in a special way so that it's two of the same or identical factors. How you do that is you take the coefficient of the x term, kind of take it off to the side, and you're going to divide it by 2. And then you're going to square it. Divide by 2 makes 2, squared makes 4. So if you add 4, when you look at just the stuff in the parentheses, it is going to be factorable into two factors that are the same. Now, you are not allowed to just add 4 and do nothing else. You have to even that out by subtracting 4 later. But actually, when you put a 4 in parentheses with a 2 out in front, you are actually adding 8. So I'm going to have to even that out or like balance it out with a minus 8. So when I go ahead and, fix that, that minus 8 is going to be the thing that, undoes what I did. So now I'm going to go ahead and I'm going to factor just what's in the parentheses. So it'll be x plus 2, x plus 2. Outside the parentheses, I have a minus 1. And then you see those are identical, so you can combine them and write them as 2, x plus 2 squared minus 1. Now, this is standard form. Standard form allows us to get the vertex easily. So standard form. Now, if I'm asked, what's the vertex? Well, the vertex is hk, -2, -1. A is positive 2. It tells me it's pointing up, and it has a vertical stretch of 2. So if I'm asked to graph it, which here, I'll graph it. I don't know if it says I have to, but I do have some graph paper here, so I'll do that. It asks me for the vertex, which I have. It asked me for the axis of the parabola. That is just the axis of symmetry. It's the line that cuts it down the middle. Let's graph it first, and then I'll show you what that is. So we did get the vertex, which we needed. And then I'll show you how to get that axis of the parabola, which is your line of symmetry. So here I have -2, -1. So there's my vertex. A is 2, so I'm going to go over 1, up 2. Back to the vertex, over 2, up 8, 4, 5, 6, 7, 8. And then back 1, up 2, back 2, up 8. So that is my parabola facing up, vertical stretch of 2, and my vertex at -2, -1. And then my axis of symmetry is the line that cuts it down the middle vertically. And so here it's a vertical line, and it is at -2. So I'd say x equals -2 is my axis. They call it the axis of parabola, or it's your axis of symmetry. Right, here is the complete the square typed. And then the graph, they did your parent function graph, and then they moved it. Finding minimum and maximum values, that's going to be at your highest point of the graph or your lowest point of the graph, really focusing in on that vertex. And so we did complete the square in order to find the vertex there. There's another way to find the vertex if you are not wanting to complete the square, and it's this little formula here. -b over 2a is the x value of the vertex. Once you have that, you plug it into the function for x, you'll get the y value, and that is your full vertex. If a is positive, your parabola is pointing up, then it's going to be a minimum value because it's at the bottom. If a is negative, then it's pointing down. It's going to be a maximum because it's at the top. Same process, just a difference between min or max. So here it says the path of a baseball after being hit is modeled like this. Now, I don't have, I'm not going to graph it for you on a graphing calculator or on Desmos or anything, but you can see your y-intercept is 3, and then the a value is negative. So it is going to be some parabola that's, facing down and looks something like this. I kind of skipped drawing that part because it's back in time, but if I draw it forward, it would look like that. Just a general picture of it. So if I'm looking for the maximum height, I would need the vertex. Now you can find that graphically on a graphing calculator, or, this is the algebraic process that you'd go through. You identify the A and the B values, and then what we would do is, apply this little formula. X equals negative B, so -1 over 2 times A. And then we'd get our X value. If you plug that in, your X value is 156.25. So that is horizontally your feet away from home plate. If you go back up to my little picture, it would be, this far over. So if we're looking for the max or min, like the maximum height here, this is how far it is horizontally away. And if we want to know the height at that spot, that would give us our vertex. It would give us our maximum height. So you take this number and you do f of that number. You plug that in for the x into the original function, and it gives you your maximum height number.